So, what is SQL injection? Well, SQL injection is a code injection technique used to attack a data-driven application. It's whereby the application is tricked into running malicious SQL statements that have been input into an application that's only expecting to get plain text at that point. So, put in a name or genre in this case in our application for a movie, and the application won't be expecting to receive an input that contains an embedded SQL statement. It only expects to see text. Or to put it another way, as this cartoon comically explains. But how does it happen? It happens by not sanitizing data which has been input by the users that contains these malicious SQL instructions. And it happens by using unparameterized embedded SQL queries in your code, and it happens where an SQL session does not have the security permissions set correctly and tight enough to prevent the acts from occurring in the first place. All these conditions must exist at the same time for an SQL injection attack to be viable. So in our example, add genre does not contain a parameterized query, but add movie does. Therefore, add genre is vulnerable to this attack, but add movie isn't. As we can see, if we examine the code again just now, we can see that add genre has got an embedded SQL in it where the genre name is basically just stuffed in the string in line there, and there's no parameters used to do it. Whereas for add movie, we've got an insert statement, yes, but instead of having the values inserted in line, we're using parameters to pass the values in, which means that this method add movie is not vulnerable to an SQL injection attack. So we're going to perform an SQL injection attack right now on application, and we're going to actually do it twice. And in so doing, we're going to permanently damage the database that underlies our application. So we're going to deliberately break something just for educational purposes and fun, because sometimes it's nice to break things rather than build things, right? So we're going to attempt two SQL injection attacks right now. The first will cause data to be permanently deleted from our database. The second will cause a table to be permanently dropped from the database, thus damaging the actual database structure itself. So I'm going to build and run the application again, and I'm going to try this. So let's just run the application first, and we're just going to verify that the database is actually working correctly already. Whoops, hang on, what's the wrong screen? Let's try again. So we're going to go and just verify that the data is there still, and we can see that yes, it is. It's running fine. So now if I go and try and add another genre, and I'm going to add it as hacked, exclamation mark, quote, bracket, semicolon. This will close off that initial first SQL statement that's in line in my code. And then do delete from movie. Okay. And then semicolon and then dash dash. And if I hit enter now, nothing appears to have gone wrong at this point. And if I go and look and see what the genres are in the database, you can see I've got one there for 7 been added. That's what I wanted to put in. It's hacked. But the rest of that string apparently was ignored. No, it wasn't completely ignored. What actually happened was if I do a list of movies now, you'll see that there's no movies in the database at all. They've all been deleted because that second part of that line has actually been executed as a real SQL statement, and the SQL server underneath acted upon that and deleted the data without any warning. So that's the first one to show deletion of data via SQL injection attack. But that's bad, but there's worse things we can do. We've only just deleted data, so you could have a backup that recovers the data, or maybe you missed too much data at that point. But let's try something more destructive this time. Let's try actually doing one where we're going to drop an actual table by using the same attacking SQL attack route. So let's go back to the application again, and now we're going to do another add genre operation, and this time it'll be hacked to drop table movie, and hit enter there. And again, if I list the genres again now, you'll see that there's hacked and hacked 2. That's fine. Those new genres, or the fake genres, is actually there. And you should have already worked out by now that what's actually happened underneath is that second part of that statement would have been run as well. So drop table movie would have been executed as well as an SQL statement, not just as an ordinary piece of string text. And that means if I now go and try and look at the movies list to see what actually is there, and I know there's none there anyway because we deleted them previously, but now if I try and do it, the application should respond differently. See, something went wrong. In fact, object name movie, it's saying that there isn't actually a table now called movie. It can't find it anymore. And sure enough, if I was to look in a database, which I won't do right now, but if I was looking at a database on the SQL server, you'll see that actually that movie table has actually disappeared from the SQL server. It's gone completely. That's not good, is it? So we've broken application, and we can actually restore it if you want to in this case, because the database itself lives in this example in the root folder of the project. So we can just do build clean solution from Visual Studio and then rebuild again, and then that will cause the database to be copied back into the bin folder again, and it's fine. That'll fix the problem on this one occasion. But in real world situations you won't be so lucky, and this is why you shouldn't be doing embedded SQL in the first place. And if you do, you've got to be very careful how you do it. You need to make sure that whenever you do embedded SQL in applications, if it's an insert statement like this, or any kind of actually statement where you're putting in data from the user as part of your query, you must use a parameterization approach as demonstrated by the add movie method there when doing it, and do not do just inline inserting of values into that SQL string, because it's very dangerous. But still, if we do that, we may have solved the SQL injection attack problem, but we have not got the problem, the wider problem we addressed earlier on, we looked at earlier on, of too much boilerplate coding, too much repetitive code being written. Because if you think about it, as I said before, what we've actually got is we've got similar code here to create a connection and actually set up the mechanisms for working with the database in this add movie class, and the same for add genre. It's all fairly similar stuff. We do similar things over and over again. And this is boilerplate code we want to try and get rid of, because remember, the keyword, the word to remember is dry. Don't repeat yourself. Don't keep writing similar code again and again and again and creating extra code that you've got to maintain and change. And it means there's more things that can break later on and more headaches for code maintenance in the future. So we want to try to avoid this repetitive, similar type code. So we want to avoid doing that, or to put it, to inappropriately extend the word of someone famous, we can say this: he didn't really say that last bit, that code maintenance, but it kind of works. There must be a better way for doing this, and of course there is, and it has a name, and it's called object relational mapping, and we'll look at that next.